In order to get into battle school, cadets have to pass a rigorous entrance exam, which includes mathematics. Help Commander Graph grade the next wave of students' tests. The last step of a problem in the matrix multiplication section is the matrix A times B times C, where A, B, and C are square matrices. Which of the following candidates have answers that are equivalent to this expression? Select all who are right for any A, B, and C. So select all that apply. So I encourage you to pause this video and think about it. Which of these expressions for any square matrices A, B, and C are equivalent to this right over here? So I'm assuming you've given a go at it. So let's think through each of them. So this one is BAC. So they have changed the order. And we've already seen that matrix multiplication is not commutative in general. And so this will not be true for any square set of matrices A, B, and C. So this is not going to be true. Matrix multiplication is not commutative. So here you have Bernard who says A times C times B. Well, we already know that that's going to be the equivalent to ACB, which once again, they've swapped the order between the B and the C. Matrix multiplication is not commutative. You can't just swap order and expect to get the same product for any square matrices A, B, and C. So we could rule that one out. A times BC. So we've already seen matrix multiplication is associative. So this is the same thing as A times B times C, which of course is the same thing as A, B, C. So what Karn has right over here, that is right. That is equivalent for any square matrices A, B, and C. That is equivalent to A, B, C. Now Ducheval, let's see. Now this looks like a bit of a crazy expression, but let's think it through a little bit. So first of all, matrix multiplication, as long as you keep the order right, the distributive property does hold. So this first part right over here is equivalent to, so let me write this down. This one's interesting. So we have A times BC plus A minus A squared. So you can actually distribute this A, and I encourage you to prove it for yourself, maybe using some 2x2 matrices for simplicity. And so this is going to be equal to, this part right over here is going to be A, B, C plus A times A, which we could write as A squared, and then we're going to subtract A squared. Well, these two things are going to cancel out. They're going to end up being the zero matrix, and if you take the zero, so these are going to be the zero matrix right over here, and if you take the zero matrix and add it to ABC, you're just going to end up with ABC. So this one was a little bit tricky. This one actually is equivalent. So this one is right, and this one is right. And then here, this is A times B plus C. So this is kind of nutty right over here. They're not even multiplying B and C. So this one's definitely not going to be true for all square matrices A, B, and C.